I thank University of Taiwan for inviting me for the talk on the occasion of fourth International Conference on Sustainable Development and Green Technology. So I thank Professor Yoming Hong for inviting me for the talk. So it's a privilege and honor to talk on and represent my region, that is Eastern Himalayan region of India, which is also known as Northeast India, to talk on butterflies of Eastern Himalaya, which is an indicator of climate change. So, as we all know that 7% of all life form on Earth are Lepidoptera, so which includes butterflies, skippers, moths. So, and that's why they are very important part of our ecosystem, and they're important part of our food chain. And since this Lepidopteran group are such a huge group, we cannot ignore them. And personally, I feel that the climate change impact on these groups will be very interesting because they are small insects and small things. We can observe changes very rapidly, very quickly. So I think climate change is happening on Lepidopteran community across whole world, and Eastern Himalayan region is not an exception. And since butterflies are celebrated of all insect groups, and it's not possible actually when you go to a forest, it's not possible to measure the biodiversity of a forest, to measure the biodiversity of all the insect community. But if we consider species like butterflies, moths, or dragonflies, then if we say that the forest is good for butterflies, then the forest is good for all insect communities. That's why we can consider butterflies as celebrated of all insect groups, and same will be for climate changes, and which we feel personally. So, and since butterflies are very diverse groups, they are very diverse groups. As you said, they have represent 7% of whole life form, and they can provide extreme detailed view of environmental and climatic conditions. So, example, if a forest is good, simply by looking at the butterflies, we can say the forest is very good. It has good quality of butterfly species, then forest is good. If the climate is changing, if a habitat is degrading, then simply by looking at the butterflies, we can say that the place is good or bad. And same will be for if the climate is not suitable for butterflies, then definitely climate change is happening. So let us talk a little on the northeastern region of India, which is connected to many countries like Myanmar, Bangladesh, and even Iran, Tibet. So all are connected to the northeastern region of India. That's why the region is very diverse and very interesting and richest areas of the world, according to the legendaries of butterflies of who worked in Asia, just like Evans, who wrote Butterflies of Indian Subcontinent. He told that it's one of the richest and most interesting regions of the world for butterflies, the northeastern region of India. And so will be, I think, the response of climate change, because the region is very diverse in butterflies, and since it's a part of Himalayan hill ranges, and therefore the response of climate change to butterfly groups will be very interesting to study in this region. So as I told, that Northeast is very diverse, but we have only, the Northeastern region has only 8% of India's landmass. Although it has only 8% of Indian landmass, so since it is connected to countries like Tibet, to countries like Myanmar, to countries like China, to countries like Yunnan, everything is connected to the northeastern region. So we have 83% of Indian butterflies. So we represent good diversity. Till now, 1,000 species has been recorded, but every year we get new records. So if we say 1,200 odd species in the region, so it won't be a risk to tell actually, because every year we are getting new records, new surprises, new species, so many things from the region. And the region has different states, and Arunachal Pradesh is one of the diverse state of the, which is actual representation of Himalayas. and very diverse state of the region which has maximum butterflies. So it's a Mecca land, and people call it's a land of dancing butterflies. So amazing place, the northeastern region, to visit for butterflies actually. And we have 1,000 odd species of butterflies, and we probably have 9 to 10,000 species of moths. And in India, only 5,000 odd moth species has been described till now. So many work has to be done in lepidodon community as a whole in the northeastern region or in India as a whole in future, and especially in groups like moths, nothing has been studied till now. Now the question is, are all the butterflies indicator of climate change? It's a big question actually. Not necessarily all butterflies will be indicator of climate change. So only some species may be indicator. So which we'll be discussing in our next slides. So, and butterflies always fascinate us because we see them in all colors. Let it be green, let it be yellow, let it be white, let it be red, anything. So they are our living wells. That's why it's necessary we should save and preserve them. and and they have very short life cycle. This is very important for from climate change angle because of short life cycle. Their response of climate change. Example, the life cycle is suppose earlier days it was 60 days. Now because of warm climatic condition, it only take 30 days to complete the life cycle of a butterfly. Then we can see so quickly and rapidly they respond to climate change, more than groups like birds because they are bigger groups, but smaller groups, smaller insect groups like butterflies, the response will be very rapid to climate change. So I have already discussed this. They have very short lifespan, generation time. So and population, their population dynamics will be greatly affected by climate change. So and same actually in European countries, it has been found that moths have been advancing their life cycle very rapidly. But in our countries like India and all, very less information is present on historical record on life cycles information. So we cannot say from safe angle actually on, but definitely the life cycle of many species are advancing a lot because of climate change. And also the butterflies are on the move, that we can definitely say, because most of the species that we are seeing in the plains in the past 100 years back, 200 years back, we no longer see in the plains of northeastern region of India or in the plains of the Himalayan foothills. Now we can get to see them in more little elevated areas. So butterflies are definitely on the move from higher temperature area to colder regions. So they are on the move, and they definitely need sunshine and their and warmth and their calorie. So and many species, example 150 species. So in last 150 years, 4 species have become extinct globally, and this is sad actually. So probably because of climate change, we may face more extinction, probable extinction in future. So that's why tracking butterflies is very necessary to be a part to know what how our environment is changing. And another question is, are butterflies and moths well equipped to cope with climate change and new temperature? So definitely it's not. Butterflies are not well equipped. Some species may be equipped, there are very common ones, but not the rare ones. And are the population under stress? So definitely population is under stress. And if you look at the European countries, so they're saying that the Apollo butterflies have advanced their elevation to 200-meter more, more because of climate change. And it's actually in our eastern Himalaya, 200-meter elevation range shift is not a big deal. So we find that elevation or species that are found in the lowest elevation, example 20 to 100 meter, we see them in 2000 meter, 2000 meter. So 2000-meter rise we get because the mountain ranges are very steep, and from the plains we get mountain directly from hills. From 20-meter we get mountains from 3000 meter within a span of 3 hours drive. So that's why mm, the impact of climate change will be more rapid in the eastern Himalaya than the European regions. So definitely the Parnassus butterflies, nothing has been studied in the eastern Himalaya actually, how much probably they have shifted the range, but we have no information on the historical records. That's why it's difficult to say actually for many species groups. Uh, and now the question is just general question: why butterflies indicator of climate change? Because they are cold-blooded invertebrates, and changing climate is responsible for their distribution. And because of changing climate, is directly linked with altitudinal gradient of the hills. So butterfly distribution pattern is greatly dependent on temperature. So simple, if because in colder region has different species, warmer region has different species, and simple change in temperature can will result in shifting range of the species in any place of eastern Himalaya. So as I told butterflies being cold-blooded, easily affected by changing climate, distribution too is greatly affected, and they are very sensitive to environmental changes, very sensitive to any kind of environmental changes. So let it be habitat degradation. So and so similar is the case of climatic condition. And let us come to the main impacts of climate change on butterflies globally actually. So what can climate change do on butterflies? So it can result in send in abundance. So if we see a species, oh, they were very common in our place every day, and suddenly we see the species is disappearing, and we are not seeing it anymore. Even the common species. So send in abundance definitely, but for send in abundance study, we need data, historical data on abundance, which is actually scarce in Asian countries. It's more in European countries, they have information from lots of historical records on abundance data, but we don't have abundance data for our Asian countries. But of course, the change in ranges, distribution area, that's a simple thing. It's present here, not present here. So that data, everyone we have it for any places of our Asian countries. So definitely change in range distribution area that we are seeing the impact, and it's a direct impact. So many species, as I told, we are seeing the plains, we are no longer seeing the plains, we are finding to see them in little elevated areas. And also change in phenology. Now phenology has different things, just like I showed example of a moth that it is emerging earlier. Sorry, the life cycle has advanced by 10 to 12 days, but not necessarily, because earlier example, if we see a butterfly to see in April, now we are seeing in the butterfly in February. Earlier we see a butterfly that it is seen from April to October. It's not seen in winter, but now we are seeing a butterfly in winter. That is also seen in phenology. Because of warmer conditions, there's no winter anymore. So that's why the species that were not present in winter, we are seeing them in winter. That is also seen in phenology. So many we are getting many evidence, dozens and hundreds of evidence of changes in phenology. And this is just elaboration, change in range, distribution area. So I won't elaborate it more. Phenology, yes, early flight, that is the change in phenology, beginning of flight period, lengthening of flight period, and generation time per year is increasing. So temperature and precipitation are main factors for early flight in butterflies. So, and the warmer climatic condition is causing butterflies to emerge earlier. So that is the direct impact of climate change. So what species that we are seeing in April, May, June earlier, we are seeing in early February. So that is direct impact of climate change. And we are seeing species with that is single brooded species, multiple brooded. So butterflies are having more children than earlier. So because of climate change, it's helping for some species actually, but not necessarily it will help the rare species, which are species that are seasonal. We are not seeing it anymore, because because the particular that season is disappearing for them. And change in abundance, so this thing, change in abundance, actually we need historical data on abundance, which we don't have for our eastern Himalayan region. But I think if we although we don't have, we should have a baseline data from now, that on abundance of species of different size, then probably in future we can compare over a span of 10 years whether the abundance is changing. But for our Asian countries and all, even for our Western Himalaya, we don't have information on change in abundance, which is a sad thing actually to study. So, change in ranges distribution area cannot be of two types: polybody shift in latitude distribution or increasing altitude ranges. So, here I am talking more on the altitudinal ranges because I am talking on the Eastern Himalaya. It has very rapid change in altitude, so I am not focusing on the latitudinal distribution, which is more in the European regions actually. Species with diapause or overwinter in active form grow winter become warmer. Yes. So because there's no diapause thing for butterflies anymore, because there's no overwintering anymore. So, and with increase in winter average temperature, this species can shift northwards and higher altitude. Yes, definitely. So species are moving to higher altitude, and as I told that butterflies are probably benefited by climate change and probably not benefited. So let's talk on both pros and cons. Like that species which prefer for low temperature will be threatened. Example, species which like only very cold temperature, it will, because things are getting warmer for everyone, so it will be a treat for that species. I like cold temperature, I don't like to be in hot place, so I have to shift my area or I have to be an next thing. So that's a bad thing actually. But if I love warm climate, I love warm temperature, then I'll be benefited. It's simple as that. That's like some species like cabbage which are so common, so it's so abundantly found, so they are becoming more abundant, so it is benefiting these species, few species. And also definitely butterflies respond to climate change differently depending on the species. And even the same species we have seen in even Eastern Himalaya respond differently in different location. Example, we have in Eastern Himalaya we have places like Arunachal Pradesh, as I told, we have places like Nagaland, we have places like Sikkim, so which are all different states, and the populated states, there we are seeing that impact of climate change is more, and in the forested states just like Arunachal Pradesh, which are pristine forest, nothing is disturbed, that is 70-80% of forest cover. There we are seeing that the impact of climate change is very less. In populated states like of Himalaya, in Sikkim, example, species we are seeing in 2000 meters. So same species we are seeing it at very low altitude in the forested states. So it is responding differently, and probably climate change might have already occurred in historical past in these populated states, and we are aware on climate change actually. It might have already occurred in historical past. And our region is very vast, as Eastern Himalaya is very vast. We have elevation from 20 meter to 8,000 meters. So I'm talking only up to 3,000 meters because high mountains, there are actually very no butterflies at all. So so we are, in our talk we are focusing only from 20 meter to 3,000 meter, but we have gradient from 20 meter to 8,000 meter. And because of this vast altitudinal complexity, we have the diverse of habitat in our Eastern Himalaya. The lowest area is called tropical. After that, the subtropical comes, then lower temperate comes, upper temperate. After the subalpine, alpine shrubs. So we have diversity of habitats because of the Himalayan mountain ranges. And this is the elevation map of the Eastern Himalaya. So so here we see the difference in elevation gradient. So we have plains, completely plains, and the plains are bounded by hills. And now what is happening? The species are disappearing from the plains and are going to the hills. And the species of the hills, the northeast hills, these are called northeast hills, they are going to the here. So this all this evidence we are getting on butterflies. So as I already told that we have very rapid change in altitude. So in our northeastern region, so that's why impact of climate change is very rapid in our Eastern Himalaya. And because of vast altitudinal gradient, we have diversity of habitats, different habitats we have, because only because of the altitudinal gradient. And as I told that the hill regions of the northeast are likely to be impacted more by climate change than the Himalayan hill ranges. So, for example, these are the hill ranges of northeast. It's called northeast hills. These are all eastern Himalaya hills. So these areas are impacted first more than the Himalayan hill ranges. Because historically, many species were recorded from the northeast hills, but we no longer see these species. But we see them in the high elevated areas of Himalayan hill ranges. So very different. So example, let's go out from butterflies to mammals to connect more to you all. That let's see the example of the red panda. Just like the red panda is very lovely animal found in eastern Himalaya. So red panda is historically known all from all northeast hill states, from all the hills. But now, and the very low elevation. The elevation is around 400 meter, 1000 meter, 1200 meter. But now red panda we see only above 2000 meter or 1800 meter. So this is the direct evidence of climate change in mammals. Forget about other butterflies. So this is a direct example on mammals. So same I think will be for butterflies and different taxonomy group also, and species that have wing. Definitely they can fly like butterflies, but species like red panda, they might have got locally extinct because they cannot move up like that from the northeast hills. So many species has become locally extinct from the northeast hills. These are called northeast hills. These are called eastern Himalayas. You can see. So this is Bangladesh. This is Tibet, Bhutan. So Nepal. So Myanmar. So you have connection from all sides in our eastern Himalaya. So that's why our eastern Himalaya is very diverse. So, and let's talk on some climate change evidences on butterflies in northeast India. Frankly, I am actually not a climate change biologist. I am just a butterfly lover. So I just have brought the facts on butterflies and try to connect to climate change. Uh, so example, this is another butterfly that is found in the Chinese region actually, Aporia, and they also this are Palearctic in origin. Aporia is found in Europe also. This Aporia genus example is found in is historically known from the Northeast Hills. This example from Nagaland historical record, but now we only see in the hills. We historically is not from here, but now we see only in the hills. So so many species are that are cold weather species are disappearing because of climate change. I mean, the species that, which are Palearctic in origin, we can simply conclude that Palearctic in origin are the first to be impacted by climate change in eastern Himalaya. So, example of the Aporia genus. Aporia genus of butterfly, which is a white and yellow butterfly group that is strictly known from the northeast hills, but is disappearing from northeast hills, but now is plentiful in the Himalayan hill ranges. And the example of Palearctic butterflies, which are disappearing rapidly. So we have Palearctic butterflies in high mountains. Then we have Indo-Chinese butterfly in mid elevations. Then we have Indo-Malayan butterflies in lower elevations in eastern Himalaya. So I already mentioned that this example is an example. It's a butterfly called Tibetan Brimstone. So it's found in Tibet and it's found in India. So so this Tibetan Brimstone is camouflaged just like its leaf has been eaten by a caterpillar. So this is how they survive in the place with high bird life. So this species, the cold climate species, the Palearctic species, are disappearing more rapidly than other species groups. And as I am trying to make connect you all to the butterflies of our eastern Himalaya and northeast India, so without talking on the distribution pattern of the species, I think it is difficult to connect. So example, so that's why I brought the slides just like this. The lower elevations, which are called lower or tropical zone, it says Indo-Malayan species in our eastern Himalaya. This species came from Malay Peninsula, and the species came from there. And in mid elevation, we have species of Himalayan Chinese sub-region, and the high elevations have Palearctic species which came from European region. So we have mainly three. But now what is happening? Because of climate change, these Indo-Malayan species are going high up to the Himalayan Chinese region. So species found from 20 meter to 1000 meter are moving up to 2000 meter to 2500 meter because of climate change, which was actually not so in historically. Now the species are moving, but not the host plants. That is a question mark. So host plants won't move so rapidly as the butterflies. So butterflies are forced to move up because of climate change and come down. So their habitat is actually going out actually. Then the place where they do egg lay, they're not no longer suitable for their them. So they have to move up, spend the time in the hills and come down. So this is all happening because of climate change. And because of our eastern Himalayan hill ranges, because of the gradient, many species has been formed. Example, these three species, example, this found in 2000 meter, they are all one species one at time. This Burmese yellow flat, this Swino's flat, which is endemic to the eastern Himalayan ranges because it's only found till 300 meter. So all this speciation has also happened because of the eastern Himalayan hill ranges, and every species is adapted to the particular elevation band, and the climate change is forcing the species to move out from its usual habitat, usual elevation ranges. So this is the stress the species are facing. And many sister species we have in our eastern Himalaya because of the altitudinal gradient. And same species, this example is found in high elevation, this is found in the low elevation, same in Thailand also. So because of the elevation gradient, so many species are getting splitted. And the lowest elevation is represented more by like skippers, black blues, and white and yellow butterflies found all around from low to high elevation. So different family are distributed in different elevation bands actually. And as I already mentioned, many species, many skipper, so many skipper butterflies, these are all Indo-Malayan in origin. They are moving up to high elevations in different places, different states, populated states of the eastern Himalaya. So you can see the species which are historically known, we are getting here, we are getting here, we are getting here, but we are no longer getting in the hills. We are getting here. So species are disappearing from the northeast hills, and we are reappearing again in the Himalayan ranges. So Himalaya is probably gaining species, and surrounding northeast hill ranges, the plains are losing species. Example, historically 650 to 700 species were recorded in Meghalaya, but at present only 500 odd species has been recorded from Meghalaya. So and in our eastern Himalaya, there's a big river which is called Brahmaputra River, which is from when Himalaya is from. It has resulted in speciation and also barrier for many species, just like the gibbons. You see the gibbon genus is all restricted to the this is to the southern bank of the Brahmaputra River. So these are all malign species. So malign species are also facing threat because of climate change. And but where will they move? They have only two options: to move left or to move up. So malign species are also facing threat to extinction, which are completely low elevation species. They cannot move high up, and only option is to move left. But because of the Brahmaputra River, they cannot move towards the left. So many species are probably in the risk of extinction from our northeastern region because of climate change. And let us talk on some facts, interesting facts on butterflies of our eastern Himalaya and northeastern region, just like just facts for general information, nothing scientific. So that's like butterflies are cold-blooded and hence not adapted to changing temperature, as we all know. They're cold-blooded, and that's why not adapted to changing temperature. So they're very important point actually. And butterflies are moving up. They're moving up the hills in eastern Himalaya. They're moving up from low elevation to high up. And uh, as I told, climate change is already evident in butterflies of northeast India, which might have already occurred in historical past. So already climate change might have occurred in historical past, and which we are studying now, but it has already occurred. Example, as I told, species in a populated states of northeast India, just like Sikkim, Nagaland. So we are seeing that in 1600 to 1700 meter to 2000 meter, but not in the pristine forest of Himalayan hill ranges. So the populated states are facing more threat to climate change as than the forested states of the eastern Himalaya. This is an example of species example which is we are occurring in up to 2000 meter in the populated states, and 1300 meter to little populated state, and never found in the high elevations of the Himalayan ranges, which are very pristine forest. Many species are moving up, and this is an example of slate owl, which is generally seen in 2000 meter, but it doesn't have its host plane 2000 meter. It has host plane around 1300 meters. So after egg laying, it has to move high up to stay in colder place, then it can come down during its favorable season. So, and some many species, example the white, as told, white and yellows are distributed more. So these species, that are elevated, that are occurring different elevations, they will not be impacted much by climate change, but the restricted range species will be impacted by climate change. And common butterflies, as I told, will have more children, just like the cabbage wise is found all throughout the elevations, is found everywhere. This species will be more benefited, and they'll have lots of populations. And butterflies are emerging earlier, as I told. So as an example, skippers, example, these butterflies were seeing after April or May. Now we are seeing in February, March. So they are emerging earlier because of climate change. And the plain areas, low elevation areas, are losing species. They're losing species. So, and they're not gaining, they're losing. For example, many species were recorded from the plain areas of the Northeast India, but we don't no longer find them. Example, this species in 1960s, it is mentioned, then it's not as yellow jezebel. It breeds in the plains. It never breeds. It's called it breeds in the plains, and never breeds in the hills. But now we never find a species breeding, or never find a species in the plain. Now only we find a species in the hills. Now it's completely a hill species. So in 40 years, I think the species have moved from low elevation to higher to little mid elevation. This is a good example of which is known as yellow jezebel. It's very common species, but we never find in the plains anymore. And many species, example like blue teeth and sailors, earlier known from the plains, but we no longer see. Many species might have locally become extinct, and many endemic species are just like Swinhoe's plat, were historically known from the Himalayan states, but populated states are losing species because of climate change. And some the forested pristine forests have still have this, they're not losing anymore, not losing species. And many species, the endemic ones, they are becoming locally extinct from places like Sikkim, because of climate change, because of population, because of many factors. These imperials, so all these example, these gorgons, this brown gorgon, this is once known from the plains, but now you never find the brown gorgon butterfly in the plain. You'll only see in 1300 to 1400 meter elevation range in the hills. So in span of 50 to 60 years, these are all literature from last 50 years. The species have moved high up, and historically how much they might have moved up. And in our eastern Himalaya, we have more warmer place than our eastern Himalaya. We have southern India, we have central India. So species of that region are also coming towards our eastern Himalaya. Many species we are recently recording from other places in our eastern Himalaya also. So other plain areas are also gaining species from more hotter climatic conditions to our regions. and and high elevation is gaining species. It's good for the hill states of Himalaya. They are gaining more species because species of lower elevation are getting rarer, and they are moving high up. And butterflies that were present in low elevation ago are doesn't exist anymore in the low elevation, but now occur in slightly higher elevated areas. And come migratory, non-migratory species, but we have to consider that aspect also when we study the climate change, whether the species is migratory or non-migratory. And and warmer winter changes butterfly behavior. Because we are having warmer winter, definitely it will change butterfly behavior. Example, skippers, earlier we said that it's never found in winter, but now we are in our eastern Himalaya, we see skipper in the month of December, January. So the skipper butterflies are earlier never found in winter, but we are seeing them in winter. So butterfly behavior is definitely changing because of because of climate change. and also the change in flight period of butterflies. So an example, this is a very blurred photo. Actually, I could have put a better one, but Bhutan Guru is one of the loveliest butterfly. I should have put a better one for the audience. Actually, it's one of the loveliest butterfly. Those who know of the Himalayas, it's known as Bhutan glory. Is found in only June, July, like this season in earlier. But now we find Bhutan glory in the month of November also. So the change in flight period of many species is increasing, and is benefiting them. And population extinct from one boundary. That is example this swallowtail Neville's windmill was known from northeast India, but there is no record of Neville's windmill. So probably because of climate change, it has become extinct from western Himalaya. Example, this is known as Krishna Peacock. Krishna Peacock once was known from the plains. It's a very beautiful name, named after Krishna, Lord Krishna. So, but now we never find Krishna Peacock in the plains anymore. It's more a hill species now. So many species are moving up because of climate change. Example, this is a sulfur species, plain sulfur. But now you never see in the northeast hills. Many species are disappearing from the northeast hills because of climate change. So I don't think anymore. Many species have become endemic, has become extinct because of climate change, and many just like this is jungle queens, dukes. Many species has become extinct because of climate change from our northeastern region, and probably now we see them in more elevated areas of Himalaya. So now let's talk on which group are in the verge of extinction or local extinction. Definitely endangered species are in the verge of extinction, definitely, and endangered species are definitely are rarer species which are getting more rarer because of climate change, and that is not a good sign for us. So that is legally protected in India, they are becoming extinct, or from most of the historically known sites because of climate change. And the species which are restricted range and endemic ones, so they are in the threat of extinction in near future because of climate change, and already locally extinct from many places. Example, this species, some seas has very narrow elevation range. So if that place become warmer, where will the species go? Definitely the endemic species are in the threat of extinction because of climate change. Many species like Naga sapphire, Kasar mandarin blue, they are all restricted elevation range species, which I think because of climate change they are facing threat in near future. Many species, see example, this is only found to 28 to 200 meter elevation. So where will they go? They have to go up, which may not be the usual habitat. Do they have the host plane at a particular elevation range? Can they adapt to that temperature? Because it's an endemic species, it may not be able to adapt to that particular elevation range. So all these are endemic species of the northeastern region. So you see, you can see they're endemic to particular pockets. So if the place become warmer, if the habitat goes away, the species will become extinct. Swinos flat, Naga, Bushbob, so all are particular elevation. See, elevation range just 200 elevation range band they are found. So since Eastern Himalaya is home to many endemic species with narrow elevation ranges, and climate change has increased risk of extinction of these species, definitely. Therefore, there's need of conservation of species or assemblages which are at extinction, and proposing a long-term conservation framework. We need a long-term conservation framework for a region based on scientifically compiled data. So to know what is actually happening in our region. An example, I talk on not the northeast hills is also known as Patkai ranges. So many species are only found in the Patkai ranges. So and where will the species go? This because they only are restricted to Patkai ranges, and they cannot move to different places, and that's why there's lots of actually problem actually for not all species may not be able to adapt to the climate changes. And why example Kesarhin is one of the loveliest butterfly found in the eastern Himalaya. It has disappeared from Meghalaya, so which is part of northeast hills. It's locally extinct from Meghalaya, which is just historically known plentiful. And because this species like Kesarhin, this is Bhutan glory, they need well wooded forests in high elevation, and the well wooded forests are becoming scarcer and rarer day by day in our eastern Himalaya, and that is the root cause of climate change. We feel the deforestation, the habitat of the endemics are disappearing, which is I think the serious issue to address. If we save the forest, then we will save our planet, our earth from the impacts of climate changes. And definitely how adapted a butterfly to its habitat, it's very important. Actually, not all species can adapt it. Warmer temperatures allows the host plant to dry up, so host plants are drying up, so many problems are there. And butterflies locally adapted are most likely to move or die off because they're locally adapted to a particular habitat. So, and habitat loss, as I told, habitat loss is one of the greatest concern in eastern Himalaya, because road widening, dam, everything is coming up. So lots of threats we have. And personally, as a biologist, we feel that we need to approach what we need to approach as a to study climate change. So we need to survey on areas which is historically records species. Example, the area was historically studied 200 years back. So we need to study on these areas to know in the present scenario what changes have happened. And we need to get a database on the geographical distribution, elevation, habitat type, season of both historical and past, and we need to compare that with our present to know what changes have happened over a span of last 100 years. So and for that, I think we need support from government, from forest department, and butterfly oriented management, that is very necessary. And public awareness, ecotourism, that is all important, necessary. And academic research, and that is also very important. And butterfly taxonomy and climate change projects, so that is all necessary for it, for study. So with this I would like to conclude. So thank you very much.